Today we're going to talk about some exponent properties that involve products, right? And product means multiplication. So what happens when you are multiplying with exponents? So let me zoom this a little bit. Okay, my creaky stand. It says, notice what happens when you multiply two powers, right? A power is like a squared. Anything that has an exponent is a power. So it says, notice what happens when you multiply two powers that have the same base. So we have a squared times a to the third. So a squared means a times a. Then we're multiplying that by a to the third, which is a times a times a. So all together, how many a's do I have? A squared and a to the third means all together there are 5 a's. That kind of looks like a 9. I probably should have used an x, but that's okay. Okay, so a to the second times a to the third is a to the 2 plus 3, which is 5. So down here on example 1, 7 to the third times 7 to the fifth would be 7 to the 8th. Because it's 7 times 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 7. Okay, number 2, we have 9 times 9 to the 8th times 9 to the second power. So what is that going to be? 9 to the 11th. 8 plus 2 is 10. This is like having an imaginary 1. So 9 to the 11th power. Okay, number 3, we have negative 5 times negative 5 to the 6th. My base doesn't change. It's still negative 5 to the 7th power. Because I have negative 5 times 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 negative 5. So that's negative 5 as a factor 7 times. On number 4, x to the 4th times x to the 3rd would be x to the 7th. Okay, at this point, why don't you pause it, do 5 through 8, and then come back and we'll check your work. Number 5, 3 squared times 3 to the 7th is 3 to the 9th. Number 6, 5 times 5 to the 9th is 5 to the 10th. Number 7, negative 7 squared times negative 7 is negative 7 in parentheses, right? We're not changing the base to the third power. And then number 8, x times x squared times x to the 26th is x to the 29th. 26, 28, 29. Okay, so now let's talk about when you raise a power to a power. So if I have a to the second to the third, all that means is I have a to the second 3 times. A to the second times a to the second times a to the second. So we can use what we learned, I'm going to switch colors, up above, right? That would be, we know if we're multiplying them, you add the exponents. So 2 times 2 times 2 is 6. Okay, and then repeated addition is the same thing as multiplication, right? So 2 plus 2 plus 2 is the same as just 2 times 3, which is 6. Okay, so the way that I learned it when I was in middle school, and I still remember it, is when they touch up high, multiply. Okay, so do y'all see how like the 2 is kind of like touching the 3 up high? You multiply. So like here, 2 to the 5th to the 3rd is 2 to the 5th. Let's think about what it means. 3 times. So that's just 2 to the 15th. Number 10, x to the 2nd to the 4th. 2 times 4 is 8. So x to the 8th. On the next one, the base is negative 6 to the 2nd to the 5th. So 2 times 5 is 10. Okay, on number 12, our base is y plus 2 being raised to the 6th, then being squared. So that's still y plus 2. 6 times 2 is 12. On number 13, 4 to the 2nd to the 7th, 2 times 7 is 14. So 4 to the 14th power. On number 14, we have negative 2 raised to the 4th being raised to the 5th. So that's negative 2 to the 20th power. On number 15, n to the 3rd to the 6th. Or why don't you pause it and why don't you do these 3 and then we'll check them. So n to the 3rd to the 6th would be n to the 18th power. M plus 1 to the 5th to the 4th would be m plus 1 in parentheses, right? The base doesn't change. It stays m plus 1 to the 20th power. And then this last one, x minus 5 to the 3rd to the 3rd. The base stays x minus 5. Then 3 times 3 is 9. So when you're multiplying them, you add the exponents, right? See, they're not touching. It's not up high. When it was a power to a power, that's when we multiplied them together. So now it says, notice what happens when you raise a product to a power. Okay, so let's see. So when you have AB to the 3rd, that's AB times AB times AB. So that's A to the 3rd, B to the 3rd. Okay, so for example, on number 18, we have 24 times 13 to the 8th power. So that's 24 to the 8th times 13 to the 8th. On number 19, okay, everything in here is being raised to the 2nd power. So that's 9 squared, x squared, y squared. Okay, and then I would never ask you to do something like this by hand, but on number 19, what's 9 squared? 81, x squared, y squared. Okay, let's look at number 20. Okay, on number 20, we're going to do negative 4 squared. So what's negative 4 times negative 4? Positive 16, and then we have z squared. Okay, and that's different than down here because I'm going to do the opposite of 4 squared is 16, z squared is z squared. And then the very last section, it just says to simplify. So let's look at number 22 first. Okay, I have 2x to the 3rd squared times x to the 4th. So according to PEMDAS, we do inside our parentheses first, right? I can't do anything inside my parentheses, but I can do my exponent. Okay, so 2x to the 3rd squared, let's think about that. It means 2x to the 3rd times 2x to the 3rd. So 2 times 2, 2 squared is 4. X to the 3rd times x to the 3rd is x to the 6th, because I added 3 plus 3. And now I'm multiplying that by x to the 4th. X to the 6th times x to the 4th is x to the 10th. So my final answer would be 4x to the 10th power. Okay, over here I have 5 times 2x squared to the 4th. So that means 2 to the 4th times x to the 2nd to the 4th would be x to the 8th. So 2 to the 4th power is 2 times 2 is 4, times 2 is 8, times 2 is 16. So 5 times 16 would be 80, x to the 8th.